Yes, perfect. Good job. All right, so in this example, again, same thing. We know that. Now, this one gets pretty confusing because you can't factor anything out, Ryan. It's tough. You can't factor anything out. But we need to find two factors. If you guys remember, we've been doing all this. We know that a trinomial can be factored as a product of two binomials, right? Yes? We know that it can be factored by a product of two binomials. And we know that the numbers for 7 and 12, we know that those answers are x minus 4 and x minus 3, right? We know that. We just did the same problem over and over. So we know what numbers multiply to give us 12 and then add to give us negative 7. We know that. The problem is we know that if we do x and x, that's going to give us x squared minus 7x plus 12. And we don't need x squared minus 7x plus 12. So if we just change the power to be x squared, it works. Because what's x squared times x squared? X to the 4th. And then let's see, that's negative 4x squared plus negative 3x squared is going to give you negative 7x squared. So therefore, I now have 0 equals this. Now I can go ahead and apply a zero product property. So I have x squared minus 4 equals 0, and x squared minus 3 equals 0. Now, is it possible for me to solve? Yes. So Anthony, the first thing I'd do is I'd add a 4 to both sides. So I'd have x squared equals 4. Then I would take the square root of both sides, and x equals plus or minus 2. Over here, I'd do the same thing. I'd add a 3 to both sides. Then I have x squared equals positive 3, square root of 3, square root of both sides. Well, can we take the square root of 3 like we did 4? No. So unfortunately, we're just going to leave that as the square root of 3. Now, again, let's talk about what we know. The degree of the polynomial is 4. How many zeros are we supposed to, how many solutions should we have? 4, right? 1, 2, 3, 4. Are all of our solutions real? Yep. So those would all be represented by x-intercepts. These would all be x-intercepts. These are rational. This would be your two irrational solutions. Right? These are irrational. These would be rational. But they'd all be real. So if you were to graph this, you would have four areas where the graph crosses the x-axis. OK? And you could also just write it or you could do plus or minus 2 plus or minus square root of 3 as a solution set, which is much cleaner, much prettier.